next experiment, what experiment says that write a Java program to implement the stack using arrays. Write a push, pop, and display methods to demonstrate its working. Let me clarify here. Just in word, I can say that this is an experiment is about to implementation of stack and its operations and demonstrate them. First, we need to understand what is a stack. Here, I will give that general definition. Then we'll see that actual meaning of the tag. So it is a kind of a linear data structure, and here the collection of element it can store, right? In which data is inserted and removed from the same end, that is called as top, right? So top is a pointer, it's presently point to the top of the stack, right? So you can take the simple example of a stack of book or stack of compact disc CDs, right? That is the best example for the stack. Yes, now we'll see that implementation of stack using Java program. First, we need to understand what we have to do that according to problem statement. As problem statement says that you need to read the stack size first, that is a n value, and program has to provide some options to choose. First option is push, second option is pop, and another is the display. These are the three operations of the stack. Then exit operation, that I will cause to exit from this looping operation. And third step is once the user chosen that option, then you can perform the particular operation with respect to those option chosen, right? And now stack consists of basically three operations. One is push, pop, display. These three operations, and it also consists of two constraints, right? You have to cope with these two constraints. One is stack overflow constraint and stack underflow constraint. And now we'll move to what is a stack mean actually. A stack is a linear data structure in which data is this is one mechanism to store the data. It is a linear data structure in which you can insert the data and pop out the data from the same point. That point is called as top, right? So you can insert the element on top of the stack, you can delete the element from the top of that, right? That's what here I have chosen that. This is only one point is open, another point is closed. So you start to insert like here, right? You start to pop out like this, right? So that is the stack 5 days. And basically stack construction is very important. First you need to construct the stack and initialize the stack. And as problem statement says that you can implement this one by, you have to implement by the array. Array is start from 0 to n minus 1, where n I have taken here 5, right? That is the size of the stack. I can say that this is size, right? And once size is initialized, initially the top is a one pointer in a stack, right? We require one pointer that is called as top. It always point to the element which is present at top of the stack. So how many elements we have here? No elements here, right? Then so where the top should be actually? The top should be, so here you cannot, right? So this is the top, no element, right? Topmost element is 0, right? So that's what top is initialized here. Then what I can see that top is equal to minus 1, right? So it doesn't mean that you can insert to initialize to 0 also, but implementation of the stack will be going to in a different manner, right? And now, so this I can say that initialization of the stack. What is the size of the stack, right? And where is the top, right? And here we have to initialize the one array. That array I can say that this is S array, right? So here can I define that S of, right, size. This is a stack size. What is size? Value of n, right? So this is initialized the stack or construction of the stack at initial point. Right. So what are the things we have to remember? What is the size we have to define, and what is the array we have to define, and of size, and top should be initialized to minus 1 beginning. Where the top is initializing to minus 1 in the sense the stack doesn't contain any n. So now we'll move to the operations of the stack one by one. Push is one operation where the item is initializing or item is inserting on top of the element. So now stack initially it is empty. where it has to initialize, right? Where it has to insert over here. So as I said that which is the top? Here top, right? So can I insert over here? No. Array is not provided at -1 index. It has start from 0 to n-1. I have to insert here. So then what you have to do that? So as I define that top should be defined initialized to, or top has to point to the topmost element. Here you are inserting one element. Assume take it as 12. It is inserting on top. Now this becomes top, right? Here you have to insert means what you have to do that? First you increment the top, right? So then what I can say that top plus plus, right? So then here I will write here top plus plus. First you increment the top. Now top is pointing over here. Now so you can put that s of top is equal to item, right? So then item, which is item here, so I am taking that item is as a parameter. So here let me take it as 12. The 12 is coming to here. Then again, right? So same top is incremented, then top is going to here, right? Now pointing to here, insert the element, right? So on. But assume that I have got inserted over here, and at the last top is pointing over here, right? One element is I can take it as 17, and all the elements are filled. Okay. Now can I call the push again, right? If the top incremented, you cannot increment furthermore. Now can I say that stack is completely full, right? This is called as constraint. While inserting, what you have to check if the stack is full. That also called as stack is overflow. Overflow means you cannot insert the further elements. So means what? We have to check the stack is overflow or not before inserting. So this is you need to check constraint called as stack is overflow. Here you have to check. How to check stack overflow here? Right? When the stack will be overflow? When the top element is equal to size minus 1. Right? When top element is, what is the size? 5 minus 1 is 4. What is the top element? 4. Right? If the top is aligned to the size minus 1, the top is pointing to the index size minus 1, then I can say that stack is full. And coming to the operation called as, I think you have been cleared about the push operation. Push operation is just it is inserting the given item on top of the stack. How it is inserting, right? Incrementing top, then inserting the element, right? That is a pre-increment, you can say that. And before inserting this item or inserting operation, we have to check one constraint is called as stack overflow, right? And next coming to the pop, what pop operation will do that? It has to take the element, right? That element on top of the stack, right? And take the topmost element and return that to where it is top, right? So which is topmost here? So here it is the top element. You have to take it out first, right? Then return. I can say that return a top, right? And what you have to do next step? Decrement the top. Once this item is pop, then what you have to do that here? So decrement the top. Now top is pointing over here. So in other words, what I can write? Top minus you can write, right? So on you continue with the pop out the element all, right? So on so, and this element is removed. This element is removed. Now so you are in this top element is top. So you have removed. Now top become here, right? So top is here once the all element are cleared. Now call the pop operation again. What it will do that? Can I pop the element? There is no element to pop out. Then this constraint is called as stack is empty, right? Or as stack is under flow. That's what before pop the element, what you have to check the constraint? Stack is under flow. When stack is under flow, actually when top is equal to -1, the stack will be empty, right? So means what? Before pop all element, you check this constraint, and if it is the constraint is not satisfied, if it is false, then only perform this one. If it is true, then we say that message called as stack is underflow. So I hope it is clear that. Now display function. What display constraint will do that? Elements are inserted like this. This is the content of the stack. It has to print the what is the content of stack. So can I say the content of stack is 14, 13, 12. You can print like this: 12, 13, 14 also, 14, 13, 12 also. But I prefer to print from top to bottom. So now can I say that this is the top point? Yes, this is the top point. From where it has to print from here to here, here. Assume that there is no element at all. Then can you display that? No. Means what? What you have to check? So constraint. You need to check about stack is underflow. Again, what you will check? So is the top is equal to -1? Then you cannot display anything because stack is empty totally. Display the message. Stack is underflow. So RL display the content one by one. Top you display. How to display it? Right? Print S of top minus. Very simple. Right? This is display function. You can do that. Print S of top minus. Goes on repeating by using loop. Right? You print this one, decrement the top. Print this one, decrement the top. Print this one, decrement until. So where you have to print until the top is reached to 0. RS top is so when top is 0, right? Print that. When top is going to less than 0, you stop the loop of the operation to print the. This is how it is push, pop, and display of the operation is performed. And very simple. Push has to check the stack overflow. If the stack is not overflow, so insert the element by using operation. If in the pop, check the constant stack underflow. If the stack is not underflow, then pop the element. Display. Check the stack is underflow. If the stack is not underflow, display the content right from top to reach bottom. That is a 0. Top to 0. So now coming to the how it has to construct with a program. See here I can say that snippet. Just I have taken one class, right? So that class is to just stack class. This is stack. What are the members of stack class? This consists of 3 members of data members. One is top, one is about size, one is about array. So this array is I can say that stack, right? To show the element of the stack. And member functions are: one is to push, one is to pop, another is to display. 3 member functions. As I said that first you have to initialize the stack. That is, you can done it by the constructor that I will explain by the program. And here I will take that what top should be initially -1. What the size should be initially? So n. That is read by user, right? And what is this size? This is initialization of the stack initially. Then call the push, right? What push? It will take the parameter integer, right? Check the constraint top is equal to size -1, right? Then what is the constant? Its stack is going to be overflow. When it is size -1. Then so it says that you cannot insert the element. If it is not, then else you insert that plus top. Why? Because of here you are incrementing first, right? Then you are inserting. That's what increment, pre-increment, then insert the element. You can write a separate statement or else in a single statement you can write it. And this is how it is push operation. Then pop. Check that first is that stack is empty or stack is going to underflow. Top is equal to -1. Then print that stack is underflow. Else return statement, right? Return the element which is presented. So top of the stack and decrement the top by next one, right? That's what return S of top minus, right? Coming to the display function, what it will do that, as I said that it check that is the stack is underflow. When it is if the top is equal to -1, then stack is going to be underflow, right? We have to print that error. If it is not, stack consists of some more elements, then you have to print the stack from top to 0. Why I am preferring top to 0 means it will print like this. Now you can understand how stack is inserted. This is first inserted, second inserted, third inserted. Right? What is the mannerism of stack? So last in, first out. LIFO is the mannerism of the stack. That's what you can understand the mannerism of it. So it doesn't mean that you cannot print from the bottom 0 to top, you can print like, but if you print from 0 to top, it will print like this. Now we need to understand this is first inserted element, second inserted element, third inserted element. Here this is first inserted, second inserted, third inserted. This is how it is a stack is class constructed. Once stack class is constructed, then so create another main class, right? Over there you create an object for this class and initialize the object by calling that object or constructor, right? Then once it is initialized by the constructor, then call the function by using switch statement, because you need some choice over here, push, pop, all. So these all choice should be in a loop statement, right, until the user has pressed proper key. That you can implement by do while statement, and that is going to repeat whenever case 1 is required, right, to call this push operation, and case 2 is required, pop operation, case 3 is required, then you can display the content. And exit means it has to break out from the loop and you have to exit the operation of the loop. So I hope it is clear to implementation of the stack by using array, and that you will see that program execution, how it is initialized, then you can understand clearly how to implement programming. Yes, now we'll move to program explanation. In this program, first I will start from import statement. I required a scanner class because to read the primitive data type, because I am reading here input data is integer, because to insert the stack, right? Stack contains integer stack it is actually. That's what to read the input I am using a scanner class. And program consists of main two classes. One is stack, which consists of stack operations and stack data is related, and this is stack class, right? Completely what are the members here, what are the data members, and what are the member functions. And another one is main class, which consists of main function over here. This is the main class. From here I am repeatedly calling the stack operations. So I'll start from I'll define you what is the stack class is actually performing. Stack consists of two data members. Those are private data members. One is top, just use a pointer to point out the top of the stack, and another is items. This I can say that container of the stack, right? Just to store the it is array, right? And then we can take it as a stack. It is actually, and here it is a constructor, parameterized constructor to initialize the object which is going to invoke this, right? So what it is going to initialize, basically it start to initialize the top from -1. So I said already, the top is -1, the implementation scenario will be different. If top is 0, implementation of scenario will be different, right? So top is -1 means once you have to increment the top, then you have to insert. While popping out, you have to pop it out, then decrement. That is the thing is there. If it is top is 0, it will happen differently. First you will increment and insert it, but over there first you decrement and pop out. This is the scenario will be there, and best it is the choice to take it as top is equal to -1. And here I am initializing what is the size they are going to pass here while creating a constructor. Then the size of the array will be created for that container of the stack. Next is this function is to push the item, and push operation required one constraint. That constraint is called as stack is full or stack is overflow. When it will be stack will be full, if the size of the stack and top is to point, or top is pointing to the value, that is size -1. Here size I am taking in the term of items length. Item is container, right? Container dot length -1, right? If the top is equal to that much, then I can say that the top is full. Else insert the top. As I said that if it is -1, you increment the top first, right? Assume that -1 means where you can insert. Array is always 0 to n-1. Then you know it is top is -1. First you have to take it to 0, then insert the data. That's what it's a pre-increment. Then you can print a message or the item is inserted over there. Then coming to the pop, what it will do that first it has to check is it the stack is underflow. Underflow means no items are there to pop out the items from stack. When it will be stack will be empty actually when it reaches to -1, right? Beginning stage. When what is that? 1 means less than 0. 0 is the most bottom or least value of the top supposed to be. If the top is 0 means then I can say that at least one element is there, right? If the top is less than 0 means no element is there, then stack is underflow and return from function. Then else uh, pop out the top element, right, and decrement the top. Returns items top minus minus, right? Just here I am printing what is the item over here, right? And top is decremented. Then display function, what it will do, that display function also requires the constraint called as stack is underflow, same what I called over there. And else you print from top to bottom. I have taken top to bottom, you can print from bottom to top also, not a matter. Just you initialize from 0 to and I is less than equal to top, you can take it, just print them. This is how stack class should be. So then coming to the main function to implement the operations sequentially. First you declare the size of the stack to store the what is the size of the stack, maximum size of the stack. And the scanner class is used to create a input buffer, that is from the scanner I am reading the primitive data type over here. Enter the maximum size of the stack by using next int. What next int will do, that calls to read the integer data from the keyboard. Then here I am creating one object called as stk. Stk is object, and along with new operator I am creating object stk, and it is causes to invoke the constructor. What constructor will do, that just it will initialize the object, that is for that particular object stk, top is -1 and item is what is the given size, that's what size is passed. And next is s boolean, just it is a flag to repeat the operation again and again. Enter the choice based on which case I am repeating this, and do this push, pop and display. These are the choice. Enter the choice, then take the choice and go to switch statement. If the choice is chosen 1, then it will go to the push item. Now just we have seen the what is the push item is going to do, but here you need to give the values what you are going to insert the element, that is enter the push item. You enter here, throw the input and next int. That next input what you read is read is going to here and it will insert, and before inserting that it will check that whether the insertion is successful or not successful and break it. Then case 2, if it is a choice is 2, then pop item. It is not going to carry any parameter, just it's return the integer and check the underflow and pop it out and come back to here. So and you can take the display option if when you choose the case 3, then it will perform the display operation what we have gone through. Same thing will repeated until you either you enter the case 4, right? So then if it is case 4 exit, right, then what it will do, that yes become false, then it will go. Other than that if you enter any value it will say that invalid choice and it will repeat again, right? Enter the push item and on. So this operation will repeat again and again until you press the 4. That's what I have taken do and while. Very simple program it is, right? I hope you understood what is the programming. Then you will see the run, what is the output. So enter the stack size. I will take a 4 is stack size, and suppose I will take a pop here, and it will say that stack is underflow because no element is there. So very beginning I am trying to pop it the item, but no element are there. Then choose the one, we will take it as 3 also. So what is saying, that stack is underflow, and you take 1. So now it is asking to insert the element. I will insert all here, and item is pushed on stack. So then you insert one more choice for the 1 only, insert 13, then 1 insert 14. Now I want to see that what is a stack display. So this is a stack contents by option 3. So these are the stack, first 12, next 13, next 14. Now I want to pop the item, so I will take it as a 2 as a item choice. Then so it will ask 14 is popped out. Now you can see that what is the content of the stack. This 14 has been deleted from stack. So content of the stack is 12 and 13. So this is how operation. I hope I have covered all the constraint and operations of the stack. And fourth is exit the operation. This is how program is. I hope you have understood the concept of stack and how to implement by using a program and what is the output, how to manipulate the output. Thank you for watching the video, and be watching a video for the next experiment. Thank you again.